All right, wonderful. Super. So it is my pleasure to introduce Doug Breeden. So Douglas Breeden is the William Priest Professor of Finance and former Dean of Duke's University's Fuqua School of Business. He also served on faculties at Chicago Booth, Stanford, and North Carolina, where he was the Dalton McMichael Professor of Finance. He was also the Fisher Black, right? So that's important, visiting professor of financial economics at MIT Sloan School of Management from 2011 to 2013. And this is actually the time when I was at MIT on sabbatical. He and I had lots of great research discussions. So it was great times. Professor Breeden published lots of very important papers on insurance prices, implicit in option prices, consumption CAPM, hedging mortgage securities. Doug was also associate editor of 5 top journals and the founding editor of the Journal of Fixed Income. He was also elected to the board of directors of American Finance Association, and in 2010 was elected a lifetime fellow. The International Association for Quantitative Finance named Professor Breeden Financial Engineer of the Year exactly 10 years ago in 2013 for being the industry pioneer. Doug Breeden holds PhD in finance from Stanford and SB from MIT. He served on the MIT's President Council, Sloan School Visiting Committee, and the Stanford Business School Advisory Council. Also, kind of along with what we have heard from other speakers, he also it's very important to also have an opportunity to work in industry and bring some of those thoughts from academia to industry, and also learn from industry and in terms of and bring it to academia in terms of research and teaching. Breeden is a senior research consultant for Munzi Smith Breeden, a money management firm that he co-founded, and Doug Breeden is on the board of trustees of Common Fund. So it is really a pleasure to invite and present Professor Doug Breeden, who will present on stock market insurance prices, Skew, and the equity risk premium. Thank you very much for coming.
Thank you, Mila. I wanted to apologize to Bob and Myron for missing the celebration at MIT September 6th. I had broken my ankle falling down a week before, and I had surgery that day. So I'm delighted to have the chance to talk about them today and some work that I've done or been part of that built on their models. So that's what I'll talk about. I was blessed when I was at MIT in 71, 72, or I was there 68 to 72. I took my first course in finance from Bob Merton with his famous mimeograph notes. And I took financial institutions from Myron. So they were both my teachers. And later on, Myron moved to the University of Chicago, and I came out of Stanford, and he recruited me there. So I was on the faculty of Myron at Chicago, and then I moved to Stanford, back to Stanford, and Myron joined me there. So I've been with Myron at all 3 of those places. And Bob Merton has been such a friend. I had both of them on boards of mine for when I was doing business things. So they're good friends. I've even got a couple of pictures here. Now this one of Fisher comes out of this next picture. We had a conference at Duke 20 years after Black-Scholes in 1993. And I'm sure you'll recognize all the people there. Mark Rubenstein was here, as well as Myron and Fisher and Bob Merton, and Bob Whaley put it together. And that was me as well. So this is a description from Fisher. I visited him shortly before he died in August 1995. And the reason I have it is because it is something that Fisher and I shared. He said, "Thanks for everything, Doug. You two combine research and applications. The results are very exciting, aren't they?" And I love that because I like doing research, and then then see it tested, and then applying it as well. Those are the 3 steps. I was blessed that my wife and I were that Bob Merton invited us to see their Nobel ceremony, and that's one picture I think I saw on Myron's wall. And then after they had a pretty rough year in 1998, as I recall, in 1999 I treated them to seats on the finish line at the Kentucky Derby, and that's Myron and Bob and Mark Wolfson along with my wife there. So they're good friends, and I wish them nothing but the best, and I've learned from them everywhere. Now, what I'm talking most about today is some of our Breeden-Litzenberger stuff and an extension that that I'm working on now. And when we did the Breeden-Litzenberger article, I just would not be complete if I didn't mention that John Cox had brought me Steve Ross's work, or maybe Sandy Grossman also brought me Ross's and Bob Lucas's work from Chicago, and we were reading those carefully. And Steve Ross's options arguments and spanning in his options and efficiency article in the QJE were really helpful to us in figuring out this problem. I just loved it. I thought it was Ross's best paper. When I was visiting at MIT in 2011 to 13, as Mila referred to it, Steve was at MIT coming up and down from Yale, and we often had dinner together when he was up there for teaching, and we talked about these articles and some of this research today. Actually, the research today that I'm talking about began at MIT in about 2011, 2012, when Litz told me he had been elected Financial Engineer of the Year, and he asked me to give a speech about him and our work together, which I did. And then I thought, okay, it's about time we did something new. You know, that 1978 is a long time. And so Bob, every 35 years or so, we ought to write another article. So we did, and we have one that just came out in the journal Fixed Income that I've been working on for those 10 years since MIT, where we applied some of this stuff to central bank policy impacts on distribution of state prices for future interest rates. So that's what I'm going to talk about today. So one of the big thank yous I have to Black-Scholes Merton is, and there are 2, really. I took the option pricing insights that I learned from them, and at Smith Breeden, where we put together what became a money management firm. We started out as a consulting firm. We studied mortgages and became mortgage specialists and modeled a prepayment option. And there were a lot of different ways in modeling mortgage prepayments that we borrowed from Bob and Myron and Fisher, and the things that we learned from them. So I learned from them and made money on the mortgage side and the prepayment option. And then the second piece was this Breeden-Litzenberger that built on Black-Scholes Merton. And then additionally, of course, the consumption CAPM stuff I did was based upon Bob Merton's work on the intertemporal CAPM. So I've learned so much from these guys. They're great. You know, this is our old butterfly spread proof that we did in 1978. This is a little bit simpler, but a butterfly spread of call options gives you essentially the payoff on arrow securities. Let's see, I don't know if I can go back. I don't think I have that capability, but I had a picture up there of Kenneth Arrow and Gerard DeBrew and the time state preference model. And what I wanted to say is that I feel like one of the best things we did with the Black-Scholes Merton option pricing model was to make Arrow and DeBrew's model usable. And so I want to mention that and give credit to Bob and Myron and Fisher that we got numbers out of here like these. This is our little pricing function that we derived that you know, the delta, what we call the delta security price, which is basically a $1 payoff in an interval, which was like an arrow security, could be had a value with the Black-Scholes model of the discount bond price times the difference between the cumulative normal at D2 at one end of the interval minus the cumulative normal D2 at the other end of the interval. I think our finance people probably know what some of that means. And we were able to come up with this table. I did a lot of, I did this stuff. And these are basically state prices that we derive for stock market moves up 10%, down 10%, up 20, down 20, things like that. And now these are not normalized by dividing by the discount bond price. So these are not quite the risk neutral probabilities. They don't add to one. They add to the discount bond price. In this paper, I normalize everything by taking state prices and dividing them by the riskless bond, zero coupon bond price for the period. So we get basically what they call risk neutral density out of it. I was pleased that when I saw that Freakonomics also picked up on our Breeden-Litzenberger technique at the bottom of the financial crisis, March of 2009. I guess Justin Wolfers wrote an article, and Eric Zeitzowitz of Dartmouth had used our model to draw essentially risk neutral densities in September of 2008 and February of 2009, looking at the nightmare scenarios. So I was pleased to see that that was being done. Now with Kenneth Arrow's securities, I'm going to look a lot at Arrow securities in this little talk. They pay off just $1 in one state of the world, one time state. And of course, with them, they're building blocks, and you can value call options and put options and all kinds of different securities. And, I think it should be very useful for capital budgeting and corporate finance, and that you can handle nonlinear cash flows that the CAPM would misprice by using the time state preference model coupled with an option valuation framework. Here, I guess, in this slide on the far left-hand side, I define a set of states that I'm going to work with in my stock market analysis. I've got a little bit of bond market analysis, and then I'm going to focus this talk on the stock market analysis. The bond market analysis we did in that Journal Fixed Income paper last year, September 22, which has quite a bit of a review of the last 20 years of the Fed's movements and the European Central Bank movement and the Bank of England's movements and their effects on interest rates. But this one's the stock market analogy. So we use caps and floors to analyze the bond market. I use options on the S&P 500 to look at the stock market. Anyway, the different states of the world that I define here are, we've got -2.5% to +2.5% on the S&P, centered around zero. Basically, it's kind of stock prices stay the same, go down 5%, go down 10%, and then the left tail, which in the calculations that I have here today is down 12.5% or more. And on the upside, stocks go up 5%, up 10%, and then there's the right tail, which is up 12.5% or more. In reality, of course, we don't just hit 5 and 10 and so on. That's why we have the ranges around them. So those are the states of the world. I guess there are 7 states of the world that I'm really looking at here in this. Of course, state prices, or as people call them also, risk neutral probabilities. And when I say state prices, I am dropping the word normalized, but it's basically always there. I do the state prices divided by the price of discount bond for the maturity it is. So if it's a 5-year state price, it's divided by the price of the 5-year zero coupon bond, so that these state prices do sum to 1, these normalized state prices. And of course, they're not the same as true probabilities, because state prices reflect both probability and marginal utility. They'll be higher when marginal utility is high. So if consumption growth is low or you're in a recession, marginal utility is high and the state price for that will be high. States that correspond to good economies will have lower insurance prices, or sometimes call them insurance prices, and they will underestimate the true probabilities. So I'll work with that a little bit later. Right now, I'll digress a little bit to the bond market work that we did with this type of model, central bank impacts on the distribution of state prices. And I was kind of surprised. I think of my own career as highly academic until I started Smith Breeden. I started Smith Breeden with Craig Smith in 1982, and then was kind of dual running business and academic career. Came to Duke in '85, and by 1992, spending too much time on the business, I thought to do a good job as a professor. So I gave up tenure and I went to Smith Breeden full time and helped build assets under management from 0 to 10 billion between 92 and 99. But I wasn't reading much finance research then, except fixed income, which was our product. And then by 99, we made enough money that I thought I can afford to be an academic again. And I came back to the academic world, and that's where I spent 1 year at Carolina before Duke asked me to be the dean. I came to Duke and was dean from '01 to '07. So I basically look back and say from 92 to '07, 15 years, I really didn't read much research in finance, and I didn't know what was going on. And so when I started looking back at it, I learned that the Bank of England was using our Breeden-Litzenberger model quite a lot, I guess, and they had some nice sites in it. And the Federal Reserve, like in Minneapolis, was using it. And lots of different central banks were using it. And I thought, that's pretty exciting. I saw the European Central Bank was also doing it, and this is the kind of risk-neutral density that they drew. I thought, well, those graphs are not very interesting on what might happen just in 3 months or 6 months from now, because usually it was either rates will stay the same or rates will move up 1/4% or down 1/4%. And that's not a very interesting risk neutral distribution. So I said to let's update this, let's do something else, and let's not use short-term options. We can, with interest rates, we can use interest rate caps and floors. And I had traded those a lot at Smith Breeden, and we used them quite a lot. And I knew they had maturities of 2 years, 3, 4, 5, 7, and 10 that were active. And we could get data on that. So we did that. And so we were using longer term options covering, 2 to 10 years. And I kind of had some analysis that was 3 year, looked at 3 years, 5 years, and 10 years, where you had to use butterfly spreads of time spreads of those interest rate caps and floors to extract the state prices. And we also, one of the strengths of our Breeden-Litzenberger approach was that it was a non-parametric approach. You could look at the call option prices and take butterfly spreads of them, and it would work whether or not the Black-Scholes formula properly priced those call options, or you had a different option pricing model, or you couldn't fit it with an option pricing model. They were just market prices that reflect whatever people know. So I liked being non-parametric as well. This is our paper that's published in the journal Fixed Income. And in that, I was developing at MIT. I was just 4 doors down from Bob Merton. He was quite an inspiration. And when I figured out some of this stuff, I went down the hall to Bob and talked to him, and I'm sure I gave him an unnecessary tutorial on some of this, but he was very kind. But anyway, I knew that butterfly spreads, when you have not discrete price moves, but continuous ones, have triangular payoffs. And if you put together these triangles together, you'd end up, like if you took a 1, 2, 3 butterfly and a 2, 3, 4 butterfly and a 4, 5, 6 and so on, all those butterflies that had a portfolio of one of each of those, you ended up with a trapezoidal payoff curve like down below. And that wasn't quite what I wanted. And I wanted to get to something that had a riskless payoff, because then what the prices have to add up to. And so I added on a left tail spread, kind of long a 2, short a 1 interest rate cap, and a right tail spread, like long an 8, short a 9. And that gave you the hockey stick types of payoffs that you see indicated. And that kind of completed the payoff pattern so that you got $1 for sure across the spectrum. And then with that, I could kind of get the prices of all those butterfly spreads, or the costs of them, and the cost of the left tail spread and the right tail spread. And this is what they were on one day. They added up to 0.977 on that day, 2012, 2013, or something like that. And that happened, that 977 corresponded to the riskless rate being about 2.3%. So when I divide each of those by the total, I get those risk neutral probabilities, or what I call normalized state prices. So that's our technique. And when we use that with interest rate caps and floors data and drew out the distribution of these state prices, it was pretty symmetric back at the end of 2003, the end of 04, 5, 6, and 7. Rates were around 4 or 5%, and the forecast for 5 years later looked like this. Some, people would say, well, they could be 6, 7, 8, or 9, or they could be 4, 3, 2, or 1, with diminishing probabilities, and they were pretty symmetric distributions at that time. And then, of course, when we fell into the financial crisis in 2008 and 2009, I remember it well. I lost all my money at that time. Wasn't so much fun, but I do remember it well. And Ben Bernanke came to the rescue in some ways in December 08 by taking the short rate to 0, and the 10-year rate dropped, I think, from 4 to 2.25 over that time. So it dropped 2, and the distribution that had been pretty symmetric even in June of 08, it was symmetric as far as the state price distribution, or risk neutral density, that you'd have drawn out in June. And in December, with rates slammed to 0, the whole distribution got kind of slammed down towards 0, and it became, instead of a symmetric distribution, one with positive skewness. It was backed up against the 0 rate and had a longer tail. So that was part of the point of that paper, is that the Fed and the central banks affect not just the level of rates, but the whole probability distribution for rates. And Steve and I talked about that. Steve Ross and I talked about some of that. And of course, these are not true probabilities. These are normalized state prices. These are the state price distribution. And of course, Steve worked on that, and we talked about those things. And I was pretty skeptical that you could really separate the probabilities from the marginal utilities. But of course, Steve has his work that says that you can under certain circumstances. Then also, after looking at the US, I looked at the Euro area, and we had cap and floor prices that we got from Bloomberg for the Euro area, and extracted state price distributions at the end of June 30, 2011, and then December 31, 2011. And that's when Mario Draghi took over, and he cut rates, much like Bernanke had in 08. And you can see the distributions move from the green bar distribution to the blue bar distribution. Again, going from a somewhat symmetric distribution to a very positively skewed one. And then when the economy strengthened in 2013 and Bernanke uttered the word tapering, and the markets kind of freaked out a little bit, you can see how the markets moved, that the price of the low rate security dropped down, and the prices of all the high rate aero securities, let's say, went up. So that was really my point, is that you could get sensible moves in state prices using our butterfly spreads of options there. This one analyzes the coronavirus. When the coronavirus happened, of course, the economy went into a tailspin, and the Fed took huge action and dropped rates down again. So that's what happened. Let me skip on here. I just updated this one. This is the US almost today. This is with October 31 data, courtesy of my teaching assistant, Jiwook Yu, and Jiwook downloaded this data. I was pushing him to get October 31. And the green, I'm sorry, the last one on the right, the orange hatch shape is the shape almost today, although the last couple of days, the rates have moved down 30 basis points, and maybe another 15 today. So this distribution would move back down a little bit. I think at this time, the 10-year rate on October 31 was 4.93. I guess we're down to close to 4.5 right now. But this is the distribution. It's concentrated more on 5 and 6% payoffs and some on 4 and 3, and it's pretty spread out. Updating the date for Europe, the euro area distribution is again the orange bar here, which is stacked up on rates higher than 3.5%. Was what was in my little worksheet that I have here. And then this is the distribution for the UK at present at October 31. And you can see how their move up in rates has moved that distribution way to the right as well for what's expected 3 years from now. So in summary on this part, you can use caps and floors or interest rate option prices to extract information about the term structure. Let's go on now. This is a bit newer stuff. And some of it is stimulated a bit by, I know this paper by Beeson and Schreindorfer and the JPE came out. And they gave us a nice site, and I thought, okay, some of what they have done in that paper, I had done some somewhat similar work on, but didn't know really the current research that much. And so let's talk about this. I've had something I've been talking about the last 5 or 6 years that we're now would call like BL Skew, Breeden-Listenberger Skew, which is looking at those state prices for the different states and left tail and then down 10%, down 5%, no change, up 5%, up 10, right tail. And look at what people are paying for the downside protection and look at what they're paying for the upside potential, the tails, and then just taking a difference of the two, the downside minus the upside. And since, you would normally pay more to hedge the downside risk because the S&P 500 is down at that time and marginal utility is probably high, so state prices will be high for the put side. And for the call side or the upside, of course, it's the opposite, and that pays off when the stock market is booming, and so that has very positive beta systematic risk. And so I computed, I did this part without Bob, although Bob, I hope is watching, and everything I do on this stuff, I have an urge to put a Breeden-Listenberger name on it because he helped me so much there. But in any case, let's go on through with the stock market option insights. First of all, I guess I'd throw up this graph that shows what I know many of you professors and PhDs know, which is that when the stock market drops or when volatility goes way up, often the stock market drops. And when the stock market drops, often volatility goes way up. So there's a negative correlation between stocks and volatility that is pretty easy to find. And a number of people have found that. As I teach this to my students, and I've focused a lot on teaching in recent years, in fact, I just taught this morning again. To explain this, I saw John Cox's notes. I asked him if I could use his teaching notes on derivatives, and he said yes, of course. And he explained it very well that because of this correlation, negative correlation of volatility with the stock market, if you buy a put and the stock market falls, and let's say it falls because volatility has gone up, then essentially the price is enhanced by the fact that not only did you win that the stock market fell and you own a put, but you win because when it fell, volatility went up and all option prices are worth more. So it gives the put kind of an even, actually it moderates the beta because it makes its price not fall so much, or no, actually it increases its negative beta because its price gains even more because the volatility went up when the price went down. So the puts are more valuable because of this change in volatility being correlated with the stock market. And that shows up in the, if you compute the implied volatilities, as Bloomberg does. I think I've got one of the next slides here. This is what we download from Bloomberg. I know this is a big table that's kind of hard to look at for a group like this, but these are the Black-Scholes implied volatilities by moneyness, by how much in or out of the money the options are. And 80% to me means that the 80% implied volatilities will give you the values of put options that pay off when the stock market drops 20% or more, and 90% when the stock market drops 10% or more. And the fact that we have 80, 90, 100, 110, 120 implied volatilities for different moneyness gives us essentially the value, allows us to compute values for the options at different strike prices. And that's what we need for Breeden-Litzenberger to use the Breeden-Litzenberger technique, is option prices for different strikes. So we use this data and extract the state prices. And this is what they look like, if you can see this. And this is during the pandemic period, March of 2020. And you see the left tail spread price goes from the end of 19, it's 19.6 cents per dollar of payoff. So essentially, if the left tail happens, you get $1 and you paid about 20 cents for it. So you would quintuple your money there. And that 19.6 goes up between December and March. And you can see it go up week by week in March to a peak of 63 cents, that you're paying 63 cents for the possibility of getting $1 if the market drops 12.5% or more. So you're paying most of the value of the distribution is betting on that left tail as of March 16th, 2020. That's the height of the pandemic. So people were really paying up for hedging then. They were scared to death. So on the right-hand side, you can see the right tail, the prices paid for the right tail also went up because volatility was much higher. Implied volatility even got as high as like 90% on some of these options. And so the higher volatility also benefits the upside. So the calls still sold for a price of like 19 cents, 14 to 19 cents, while the puts went from 20 cents to 63. And then on the far right-hand side of this table, I've got my calculation of the left tail price minus the right tail price. And you can see that goes from 6 cents up to 44 as people become very fearful and pay up for those things. So that's what we find. And that allows us to analyze, kind of what the markets are thinking. Now, or how risk averse the markets are. I've got a piece at the very end of this. I guess I'm going to have to be getting to the end of this in just a few minutes. What I have here is that this is an old state preference formula that the price of the state contingent claim, which is fee TS, is the price of $1 times T state S divided by its probability, and that should be the expected marginal utility in that time state divided by the average marginal utility of that date. And I did this, I was asked by the Federal Reserve to a conference in 2017, and I did these state price calculations, which are the three left-hand bars, the blue, the red, and the green. Those are the state prices in 2015 and 2016 and 2017. And you can see that the left tail has the highest state prices. And then and then the right tail has low state prices. But then I went out and got the data on what the frequencies of various moves were. Just computed the frequency distribution of stock price down 12.5 or more, stock price down 7.5 to 12.5, different things like that. And those are the two right-hand bars, the frequency distribution using a 90-year sub period and using a 20-year. And so I could look at state prices relative to frequencies. And I noticed that, like, if you look at them, of course, the left tail has higher state prices than frequency because that's high marginal utility. But the 90 and 95 have much higher state prices than frequencies, a big multiple there. And I think that, and that's where I could tell they were really, risk aversion was really showing up in the down 5% and down 10% scenarios. And if you look at the up 10%, you can see that the prices of up 10% and up and the right tail are very low prices and very high frequencies. So you can really see risk aversion in this table. And that's what I talked about at the Fed conference on volatility and uncertainty. And indeed, these are the multiples here. If you look at the price to frequency, you see the multiples. This price to frequency should be marginal utility. And you see, like the down 10% case, you've got a 5.8 multiple, that the state price is 5.8 times the probability, and then 3 for the next one, and the left tail is only 2.8. So you see kind of more risk aversion in the for 5 and 10% moves down than even for the bigger moves down. And that's, I think, somewhat consistent with what Bies and Schreindorfer do, is they kind of break into decomposing the risk premium for equities. So that's what I do here. This looks at more, not just what happened in 2015 and 2016, 2017. This looks at the last 20 years of data that I have, or 2005 to 2013. Same general picture there. Okay, I think I need to wrap in a minute, so we have little time for questions, or a few minutes. I also looked at the betas of Arrow securities. So I basically set up the butterfly spreads to get the Arrow security payoffs and prices. And if you think about it, for an Arrow security that pays $1, its expected payoff is that $1 times the probability of that state. So this is one case where you've got a security that you know what its expected payoff should be, the probability. Now, when I if it sells for 20 cents and the probability is 60 cents, I guess, then you should have a return on that and expect a return of 200%. And this is what the expected returns come out to be down at the bottom of this page. For the hedging side, the puts, you should expect to lose 59%, 72%, 69% of what you pay on that insurance. And then for the upside, you get them so cheaply, your expected return is like 200% on the securities. So I thought that's kind of interesting. Now the BL skew, this difference between what they pay for the downside and the upside, that's the blue bars here. You can relate it to the stock market. And what I did with that is to say, I'll bet this, what I'm calling a skew, the amount you pay for the downside minus the upside, is probably measuring a lot of risk and risk aversion. And at times when people are very risk averse and prices reflect that, prices are low and subsequent returns are probably high. So that's what the correlation I looked for was, and that's what's in this table. Like the first column gives correlation of dividend yields with future returns for 1, 2, 3, 5, and 7 year. And then the second one is the correlation of what I'm calling BL skew, the left tail minus right tail, correlation of that with subsequent returns. And it's very high for long-term returns. So that may be picking up risk aversion and risk and being a reward for that. I also find that the amount being paid for the very low rate scenario, rates below 1.5%, generally are correlated with recessions and high risk, and they also are forecasters. So that's some research that I've done. Tighan Jha, who was at Stanford and a former colleague, now she's in the UK teaching, computed the t-statistic for this overlapping data for me with a heteroscedasticity and autocorrelation correlation. Okay, and then this is where I guess I'll finish, and these are kind of our skew versus future returns for over 3 years and over 5 years, and there's a pretty good correlation that you can see, and it's a little bit better than the correlation with the dividend yield model. So to wrap up, I just say thank you, Bob and Myron and Fisher, for doing the Black-Scholes-Merton option pricing model. It helped us try to apply state pricing, and I think that this is something that should be taught in future classes to our students, to our MBAs, and not just to our PhDs. Sanjay, I think you wanted me to stop at about this time. I see 12:40 on my clock, and have a few minutes for questions. Is that right?
I think that is good. That is very good. And we can have even more than 5 minutes of questions, because this is, after lunch, they will be coming back at 1. So maybe 5 to 10 minutes of questions, So let's see if we do have any questions. Do you have a question, Hussein, or Chad?
Yeah. Hi, Doc. Good to see you.
Hi, good to see you.
So I have a couple of questions. You showed that really intriguing graph comparing the frequencies with the prices, how they change, and you sort of extrapolated that, this different degrees of risk aversion for different sort of left hand side. So what's your intuition for this? Is this institutional? In other words, you have some institutions that are hedging, or some of these buy rights and ETFs and so on. Is that sort of what's driving it? Because it doesn't seem to be consistent with rational investors, right? Having basically uniform risk aversion.
Yeah, actually, with the multiples that I get out of that, where I look at the price to frequency multiples, you can look at the theory, and it should be marginal utilities that we should be picking up. Where the multiple should be, like, if the multiple is 5 to 1, it means that the marginal utility in that state is 5 times the average marginal utility. So, I never thought about really measuring marginal utility, but these multiples kind of help us do that. And this says that the marginal utility is actually higher for some of the higher wealth states, the ones that are only down 5 or 10%, than it is for the tail, which would be something that would kind of violate most of our normal assumptions. But I think what's going on is that maybe people aren't worried about the tails most of the time, the big risk, and they're just saying, I'll just cover 5 and 10% down. Maybe 10% seems to be the one where it shows the most risk aversion. So the 90 number here is down 10% on average. And I think a lot of people just say, I think that's what I'd like to cover, that type of risk. And maybe they don't bother to cover the left tail, or they don't, they want more coverage than just getting the left tail. They want the down 10. And then in contrast, when you get to a real crisis, such as the pandemic in 2020 and 08 and 09, at those times, it may be that risk is so large and in their face so much that they worry about covering another down 12.5 or down, another big tail. And that's why they then pay up a lot for the left tail. So I think it may be related to that, on what they're thinking about and how big they think the risk could be.
You touched upon my next question, was to what extent the sort of, if you look at these as a measure of risk aversion, or at least changes in or the degree of risk aversion for different estates in the future, have you looked into see how they kind of respond to events? Do they change radically, or this is kind of a slow moving sort of process, these risk aversions for different states?
Well, yeah, that's, pull up that graph again. It's all went so fast. It's probably like a motion picture. Let's see. I think I've got that, what the time series looked like back here. Oh, no, I missed it. All right. Anyway, it moves around quite a bit. You know, whenever we come upon a crisis, it moves pretty fast. The skew. So I was looking for the skew. This
I
is,
think I saw a graph of it. Yeah.
yeah, I have it here, but I'm just missing it right now. All right. Sorry. This has it kind of, the blue bars are the skew, and you can see this is in the pandemic of 2020. If you look at the left side of that, it rocketed up and then kind of came back pretty quickly from 45% differential to 30%, and then slowly from there on down. And then it built back up again in 2022 when we were having the war, Russia and Ukraine, and inflation was picking up. It jumped up, or it moved up there relatively smoothly up in that one.
So I have a question.
Go ahead.
Yeah. So, some of my research uses the concept of state price density. So we came up with something called expected future state price density. So the idea, the second derivative of the call option with respect to strike, giving you discounted state price density, state price density, which is the discounted risk neutral measure. So that idea, if you extend it to expected future call price at its maturity, so you take an expectation of the call price at time capital T, and today small t, and option matures at capital T, then you get physical density, second derivative of the expected future price, and we call that expected future state price density. And that can be used to model, option returns. So the idea is we look at these BL skews day by day, but there could be a way to look at the returns on BL skews, like a state which is, let's say, 50% down, and then you come forward after 3 months. What is the return on just that state? And that concept can be the expected future state price density, and then return on state price density. So I find there are some very interesting relations with these derivatives. You take the second derivative of the expected future call price, you get physical density and similar concepts. And wondering, what are your thoughts on that? Yeah.
My thoughts on that is I think you were not sleeping the 15 years that I was sleeping. And I think sounds like you've gone beyond what I have here. My model here today that I'm talking about is very simple, and yours. I wish I knew it. I wish I had derived it, but you'll have to explain it to me slowly.
Yeah, it's very straightforward, just like second derivative, and you get it. And so that is what sometimes I get perplexed by, that some simple results are there, but they've not been derived, and you wonder, anyway. So. We're doing some research on that using recent option prices. And my other question related to that is, do you think option markets are more informative or more emotional? Meaning, do you think they're just reflecting more fear and greed, or they are reflecting more inside information? Because if it's the latter, then we could use these second derivatives of expected future call prices to actually get some real information. But if it's only emotions, then we can just use them to trade and make money. So in your experience, are they more informative, option markets, than stock markets?
Well, I'm reminded of Warren Buffett's comment that in the short term, the stock market is a voting machine, and in the long term, it's a weighing machine. And I would think that the same thing would be rather true of what you described for options. And in the short term, it could be emotionally motivated, but in the longer term, with all the trillions of dollars out there to invest, billions and trillions, it ought to be more of a weighting thing, and it should reflect, real risk and return. I guess I've come to believe that risk aversion changes quite a bit over time, and that you might call that emotional there, but I think people's behavior towards risk changes quite a lot, and modeling that is a useful thing to do. I remember Fersen and Harvey, Wayne Fersen and Campbell Harvey did a paper, I think like in '91, where they tried to disentangle movements, and I think they found more movements in the pricing of risk than in the quantity of risk. And I believe that may be characteristic of some of these markets.
Which means if we have to even go beyond our expected utility models, we need kind of stochastic utilities where the parameters of the utility functions are changing, but which we've not modeled in finance so much, except for some recursive utility models, but there's no model for how fear may evolve and how that affects the utilities and how that affects.
Yeah, I think that would make sense. I see my good friend Daryl Duffy has appeared on the screen. Hi, Daryl. How are you doing? And you're next up, so. All right.
Great. So I think, yeah, that was all from me. Hi, Daryl. So we will start your session at 1. We want to thank Doug Breeden for coming here. And I don't think there are any more questions, Hussein, in the Q&A.
I don't see any hands in the audience, so that's it for now. Thank you so much, Doug. It's good to see you. And again, thanks for participating in today's.
Thank you very much.
Hi, Daryl. We're going to start yours in about 10 minutes or so, okay?
10 minutes.
Very good.
Have a good day. Wonderful day. Thank you.
Thanks.
Thank you,
Good
Doug.
luck, Daryl.
Good to see you, Doug.
All right. Please take my